lesson, we will see how to create a digital model from a point cloud in the Rhino platform. Rhino is primarily a modeling software that works by creating NURBS surfaces. It is not a software intended for BIM modeling. The point cloud, the result of a digital 3D survey, is made up of a set of points characterized by spatial coordinates x, y, z that reproduce the geometry of the surveyed object. Point clouds can have a high degree of complexity and heaviness, so it is better to carry out decimations, perhaps using distance parameters. In our case, we kept 1 point every 5 millimeters and we organized it in Cloud Compare environment. The most used format for point clouds for this type of modeling is E57 extension, which we can directly import into the Rhino environment. It is possible to use the Zoom Extends command to center the view of each point cloud in the 4 viewports. The first step in modeling is to make sure you are working with the correct unit of measurement in the work environment. So we go to set the unit of measurement meters in the lower bar instead of millimeters. In this way, the model is scaled according to our needs. The point cloud is proportionate and scaled, but placed in a generic layer. To facilitate modeling, we can create new layers using the New Layers command. Each layer can be turned on or off using the On command or locked using the Locked command. Creating a series of layers facilitates the management of the different components of the modeling. It is advisable to create several categorized ones. For example, we create the level point cloud, construction, and clipping plane. It is possible to manage the different elements, select them, and change the level of the objects by right-clicking on the layer and selecting Change Object Layer. For modeling purposes, it is useful to create section planes of the point cloud to have a more accurate visualization, for example, in wall profiles. In the clipping plane level, we use the tool to make sections of the point cloud by selecting Viewport, Layout, Add Clipping Plane. In this way, a cutting plane is created. A peculiarity of the clipping plane command is that it is displayed only in the view in which it was created. To visualize the cutting plane in other views, we select the plane, click on Properties in the sidebar, and select and activate the views in which we want to visualize the section. In our case, we select Perspective, Front, Right. It is convenient to orient the axis of the X-plane, red line, and Y-plane, green line, according to the point cloud to have a predefined orientation during the modeling phase. To modify the orientation of the plane, we place it here on the constructions level by double-clicking on it and activating the layer with a flag. The orientation of the plane is defined by a line that we create according to the desired inclination using the Curve Tools single line command, making sure to activate the Project command in the lower section. Define the inclination line through the Set C-plane by X-axis command. We select the starting and ending points of the reference line, thus rotating the C-plane. It is important to check in the option on the right sidebar that Named C-plane and Named View are active. At this point, it is possible to save the plane by going to the right sidebar of the Named C-plane section and saving it with the name we prefer, in our case, C-plane 01. Thanks to this feature, we can save multiple planes based on modeling needs. If we want to return to the original condition with orthogonal axes, it is possible to select the C-planes menu and open the view, for example, Top, and select World Top to have the original orientation. Similarly, it is possible to create alignments of the plane along the Z-axis by selecting the perspective viewport and using the C-plane Set C-plane elevation command. it is possible to align the plane in the height along the x-axis. To ensure greater precision, it is possible to activate the Point Object Snap command in the lower bar, which allows point-to-point alignment compatible with points from the cloud. As in the previous case, it is possible to save the different planes along the z-axis by differentiating between different planes. Once the workspace is set up, we can proceed with modeling. Set the plane on the z-axis where you want to model. Select the construction layer, activate project, and use simple shapes to draw the building's geometry. Activate the Curve Tool Rectangle command in the left sidebar to draw a rectangle. If there are complex figures, you can use the Curve Boolean command by selecting all the geometric figures you want to merge, clicking inside the figure to keep, and pressing Enter. This way, the software creates a perimeter line of the initial figures. If the figures are placed on a plane that is not the one that we need and we want to reproject them on a different one, we can shift them on the right one. From the Transform menu, use the Mapped C-Plane command. Select the objects, press Enter in the command bar, select the C-Plane command, type the name of the C-plane, in our case Z01, and press Enter. Finally, we can proceed with modeling. It is possible to create surfaces using the Surface tool, Surface from Planar Curve command, and extrude the perimeters we have created using the Extrude Straight or Extrude Surface commands. Thanks to these commands, it is possible to model with geometric shapes adhering to the point cloud, ensuring high precision and accuracy.